Okay. Hello, sophomores. The rest of your block 4, you want to give a shout out to the sophomores?
I hate the sophomores, so.
Okay, someone, I won't mention any names, is being rude, but the rest of them, I'm sure, are wishing you a happy day. Okay, hopefully you're having a good retreat. Meanwhile, we're continuing our look at section 6.1, Law of Sines, and we're just talking about the fact that if you have two sides and one opposite angle, 3 possible situations can occur. Either no such triangle exists, one triangle exists, or 2 different triangles are possible. So I have a little activity that hopefully will help you understand this better.
Can't hear you. You have to yell. Your wife's in the computer.
You guys over to?
Yeah, I don't know what I'm like that.
Law of science.
You have to yell and stuff. They can't hear you.
Thank you very much.
Okay, so hopefully everyone has one of these. And what are we looking at for those of you watching this video at home? We are looking at this, all right? It is the Law of Sines activity investigating SSA, the ambiguous case. And I only gave you the first 4 examples. See page, what page was it? Page 432 for all of the examples, but I only looked at the first 4 examples on page 432, meaning the cases where the angle A is less than 90 degrees. In other words, you have an acute angle for angle A. So I want you to do this with me, please. All right, it says in the sketch below, you are given a triangle with side length A, side length B, and angle A, where angle A is acute. Note that H has been drawn in. What's this H? H is the going to be the perpendicular, okay? It's going to be the perpendicular here across from angle A, and you know that if this was a right triangle, and it is by drawing this H, that we have, using SOHCAHTOA, that the sine of angle A would be equal to what over what? SOHCAHTOA. Here's angle A. H over B. Thank you. So that means if I want to solve for H, H is equal to B times the sine of angle A. Would you agree with that? All right. Okay, so now how many triangles would be possible? I'm looking at example 1 right now. How many triangles are possible if side A is going to be less than H? So in other words, if I have side A, and I don't know how far to put it, but let's say it's about this long, it's got to be less than H, how many triangles would be possible? 0 triangles, right? This side A here is never going to reach this side of the triangle, so it's going to be no triangles possible. Sketch the triangle possible, but it's not possible. Are we understanding this?
Yeah.
Okay, take a look at example 2. For example 2, how many triangles are possible if side A has a length equal to H? And sketch the triangle if possible. So how many triangles would be possible then? Just one triangle, and what kind of triangle would it be? A right triangle. So it's if A is exactly equal to H, then A would be this side right here, and it would be the same as our height. All right, so the triangle that would be possible would be this triangle right here. Okay, it would be a right triangle. All right, let's take a look at example 3. It says how many triangles are possible if side A is greater than side B. If side A is greater than side B,
Any right angles or?
so here's side B, but if I make side A a little bit longer, if I can play around with this, maybe I can. No, it won't let me. I'm not in Smart Notebook, I'm just on a page here, so it's not going to let me rotate. But if you were going to draw a side length A that's longer than B, would there be a triangle possible? And if so, how many triangles would be possible? Understand what we're doing here. We're keeping this angle fixed. This angle A is given to us. This is fixed. We can't change that. This side B, this length right here is fixed. We cannot change that. And if side A is also fixed, and side A happens to be longer than side B, where are we going to put it? Well, it's going to have to be over here somewhere. Would you agree? Okay, so that means that it might look something like this. Hopefully I drew that side A so it looks like it's a little bit longer than side B. Agreed? All right, so that means that my triangle would look like this. I'll try and trace over my triangle. How many triangles would be possible?
One.
Just one triangle we just drew. Are we okay with this? All right. And what about, let's see, is it a right triangle?
No, like, I'm saying, like, if you moved it, if you extended the A value on, like, a little bit more,
Yes?
couldn't there be, like, infinite possibilities for the amount of triangles?
Yes, but if A was a fixed length, like let's say,
Oh, okay.
let's say B is equal to 12,
Makes
and we have some A value like 15, it's fixed. And angle A is, let's say, 30 degrees or something like that.
Yeah.
Then there's only going to be one triangle possible that will fit that criteria.
Okay.
Okay? All right, let's take a look at example 4 here. This one says, how many triangles are possible if H is less than A and A is less than B? In other words, let's say H is 5, let's say B is 8, and let's say that A is something in between 5 and 8. In other words, let's say A is 6. If A is 6, then how many triangles are possible, if any?
2.
Why 2?
One to the right of H,
Come on, draw.
one to the left.
Come on up.
Let's go, Larry.
Okay, so, all right,
Probably
stop.
not to scale.
All right, stop. That's fine. Stop for a second. So you're saying, let's see, let me get this up. Go ahead and draw that in again. So this is your segment there. Okay.
I don't know.
So,
yeah,
this
yeah.
one, we said H was 5, and we said this is 6.
Yeah.
So Loretto's got one triangle going here that looks like this. Everybody agree?
It's all right.
Okay. Is that the only triangle possible? Loretto, you're saying that there's another triangle
Yes.
possible? What would it be? Well, let's wait. Let's
Oh, that's right.
switch your color. Okay, go ahead. Whoa. Do people agree that that's another triangle that would be possible? Thank you. So the idea here is those two triangles, this one here, right? I'll set that one here, and this one here have some of the exact same information. This angle is still, let's say, 30 degrees. This side here is still 8, and this side here is still 6. But this side 6, and maybe we could have drawn this, it probably would look more like this, right? This versus this. But you get the idea how two different triangles are possible. Does that make sense? Okay, so with all of that good information, let's try 5 and 6, and I am going to pause us here so we can just... Okay, so for this first one, when you work this out, did you set up sine of 59 degrees over 4 equals sine of angle B over B? No?
Almost.
We are using law of sines,
We drew
correct?
triangles.
That's what I did.
So we want to cross multiply here, and we're going to get that, B times the sine of 59 degrees has to equal 4 times the sine of angle B. Agreed?
Yeah.
Right? Oh, what am I supposed to be filling in? Oh, was I supposed to fill in 13 for B?
Yes.
Yes. All right, so that's a 13, that's a 13. So if we want to solve for sine of B, we're going to need to divide both sides by 4. So we're going to get that the sine of angle B is equal to 13 times the sine of 59 degrees over 4. Calculators, what do we get?
27.2. Yeah.
What sign?
Yeah. What do you mean?
Did you get an answer?
Uh,
191.
160. Yeah, 163.
So I am going to press menu,
There's some
calculator page. You got discrepancy of some sort?
Yeah. I don't think
Looks
anybody
like
has-
I want 13, 13 times sine of 59 degrees over 4. So if I'm here, I'm going to do fraction template.
159.
I want 13 times the sine of 59 degrees. I'm in radian mode, so I got to override that with the degree symbol, over 4. And so I'm getting 2.786 approximately. Do people agree? Okay, so 2.7, I'll just say 2.79 for conversation purposes. So that means I'm getting that the sine of angle B is 2.789. Did I say that right? Right? Yes?
Yeah.
Close enough?
It's
What was it? What was it? 7, 8.
7, 9.
7-9.
Come on.
Stop right now.
Let's see, 2.79. Gotcha. All right, so 2.79. We're just going to go with that. So if that's the sine of angle B, how do we find angle B? Arc sine. So go ahead and do that. What's the arc sine of 2.79?
I got an error.
Why did you get an error? Why is there no angle that has a sine value of 2.79? Because it's bigger than 1. Because you can't have an angle with a sine value greater than 1. You know sine values oscillate
First grade
between
stuff.
1 and -1, right? So that means there is no such triangle. No triangle exists for number 5. Are we okay with this? Focus, please. All right, so now we're going to try number 6. All right, I'm clearing this ink off, by the way.
We just drew the triangle.
Yeah, we just drew the triangle and said, like, probably not. Not
Okay?
sure. Shout out to the sophomores. Love you guys. Alright, let's do this.
Oh, wow.
What was that?
That was like that Chief Keef clip.
That woke you up. I don't know why it keeps doing that. That's really annoying me. All right, talk me through how you're setting this up, Brandon.
Alright, I set it up, sine of 58 over 4.5,
Equals?
sine of b over 5.
Do people agree with that setup? Okay, and so you're cross multiplying and solving. So we're getting that the sine of angle B is going to be 5 times the sine of 58 degrees over 4.5. You're putting this into your calculator. We're shooting for some number between -1 and 1, right? Otherwise, we're not going to have a triangle possible at all. So we need 5 times sine of 58 over 4.5. 5 times sine of 58 degrees over 4.5. Are you getting 0.9423?
Yes.
Okay, so 0.9423, okay, what units is this? So it's 0.94 degrees? What is this?
It's rad.
So this is the what? 0.9423. 0.9423 is the what? Sine of angle B. 0.9423. And so I'm going to find angle B by doing what? Arc sine of 0.9423. And what do you get? 70.44. What units?
Yeah, okay, I agree.
Degrees? Do people agree with this?
Yeah.
Okay. Question for you. Is 70.44 degrees the only angle that has a sine value of 0.9423? This is where I'm going to ask you to think about the unit circle. Here's our unit circle. And remember that 0.9423 would be the y coordinate. And let's say here's, here's 70 degrees, might be like 70.44 degrees might be right there. You with me? This angle right here is 70.44 degrees. And I don't know much about this ordered pair, but I know that the y coordinate is what? 0.9423 is the y coordinate. You with me? Is that the only angle between 0 and 360 or between 0 and 180?
No, it's not.
No. Where's the other one? What quadrant would it be in?
2.
Quadrant 2. So in other words, there's this height here. This height line is the height of 0.9423. So here's a height of 0, 0.5, 0.6, 0.7. You with me? And once I get up to a height of 1, I'm at the top of my circle, right? But right here at 0.9423, that's where it intersects for this 70-degree angle. But then there's going to be another angle right here. You with me? That's also going to have a sine value of 0.9423. So there's some other angle that has a sine value of 0.9423. What is that angle going to be? Brandon?
I'm sorry, what did you say?
Brandon, I need you to focus.
Okay.
If this angle here is 70.44, then what's this angle going to be? How are we going to find that?
Subtract
Leah?
180 minus 70.
Because if this angle over here is 70.44, that means this angle over here is also 70.44. So if I want to find this angle in blue here, then I'm going to have to take 180 minus 70.44, and that gives me what? What's that get me? Your whole,
0.56.
what is it, 109? 0.56 degrees. So that's the other angle here, 109.56 degrees is the other possible B value. So I'm just going to say another possible B angle would be 109.56 degrees. But hold up, we don't know yet that the second triangle is possible with an angle of 109.56, because we would still have to have room for our third angle. So in other words, what do we know about this triangle so far? We only know that angle A is 58. Angle A is 58 degrees. Angle B could be 70.44 degrees, right? And if that's the case, what would be angle C? I'm just talking about the first triangle where angle B is just 70.44 degrees. Calculators. What's our third angle going to be? 51.56. Do people agree with that?
Yeah.
Tara, how'd you get that?
180 minus 70.44 minus.
All right, 180 minus 58 minus 70.44 leaves us with this one. Do we agree? Okay, so that's our first triangle, triangle number 1. Is there going to be a triangle number 2? Well, maybe. Let's test. So triangle number 2, question mark. okay? It's still gonna have the same initial information. Angle A is gonna be 58, but now we're trying for angle B to be 109.56. Is there room for an angle C? Or are we over 180 degrees already? If there's still room for an angle C, then we've got a second triangle. Does this make sense? Do we have room? What's angle C going to be? 12.44 degrees. Do people understand what we're talking about? This makes sense? Okay, so can you please finish this problem up? What do I mean by finish this problem up? We found for triangle 1, we found angle A, angle B, angle C, and we know that side A is 4.5 and side B is 5. I need you to find side C using law of sines. And then same thing here, 4.5 and 5. So we know that A is 4.45 and B is 5. Is that right? Yes?
Yeah.
So you need to find side C here. Okay, give you a minute to do that. And I'm going to pause the video while you're doing that. Okay, so talk me through this. How am I going to find the side C in triangle number 1? What should we do? Kayla, Mark.
So I did sine of 58 over 4.5. That's your angle A and side A.
Okay. Has to equal.
Equals sine of 51.56 over C.
Okay. And you ended up getting C equaling what?
4.16.
4.16 inches, units, whatever it is. Do people agree with that? Independent confirmation from somewhere else in the room.
I got 4.5,
You got 4.5?
4.49.
That's a problem. All right, so we basically, well, let's check this then. We want to do 4.5 times sine of 51.56. Okay, guys, we're going out past Mrs. Hertz's office. All right, you're lining out there, and I'm counting 8 heads. Stand in a single file line for me, please.
Oh, it's plus 2.
Is that so? Okay, sorry about that fire drill. Okay, so, sorry about the fire drill. Sophomore, sorry I left you running, but, you know, I'm not gonna, it's everybody for himself, you know, when the fire drill comes, and I just didn't have time to stop the video. So hopefully you paused through all of that. I mean, fast forwarded through all of that. Okay, so now we're looking at the other triangle, because we just checked the 4.16, and that looks good. So for this one, how do we set up to find C in this case? What should we do here? Sam?
Oh, okay, define C, is that the one we just did?
Yeah, but we're in triangle 2 now. We did
Oh.
find C for triangle 1, but remember there's 2 triangles possible here.
Okay, so sine of 58,
Okay?
over
Degree.
sine of, or I mean, A equals 4.5, so 12.5.
4.5 equals what?
Hold on, let me write this. Equals, sine of 12.44
Okay? Over
over, 4.5, or I mean, excuse me, C.
over C. Everybody agree with this? So if we multiply this out, cross multiply and solve, we get 4.5 times the sine of 12.44 degrees divided by the sine of 58 degrees should equal our side C. Does everybody agree with that? So 4.5, 12.44. So I think what I can do is not retype all of this. I can just go up, pop this up, push enter to pop it back down here, and then I can just edit this, right? Because I need this to be, what was it? 12.44? Everybody see how I did that?
Yeah.
All right, I'm getting 1.143. Do people agree with this? All right, now one other thing. I want to write this in here. 1.143 units. Now, here's what I want you to notice. Let me slide this out of the way for a minute. As a check, your largest angle should be across from your longest side. Your smallest angle should be across from your shortest side. Is that true in triangle 2? Everybody agree? 109 is the biggest angle, and it's across from 5, which is the biggest side. 12.44 was the smallest angle, and it's across from 1.143, which was the shortest side. Is that also true in triangle number 1? Largest side here, largest angle here was B, and it's across from the longest side. Smallest angle was angle C at 51.56, and it's across from the smallest side. Are we okay with this?
Yeah.
All right, so at this point, I am going to ask you to take a look at this application problem. Have we talked about bearings in this class? No. No. This is a red letter day then.
Yay!
Oh, so sorry.
All right, so, and I'm just going to pass the tape around, because you may want to just take this little example into your notes so that you have this example and it's preserved in your notes. All right, so I just gave to everybody, for those of you watching at home, I just gave to everyone this example, where is it? Here. All right. And let me see if I can,
On an angle.
there we go, finally, okay. So here's what I have. On a small lake, a child swam from point A to point B at a bearing of north 28 degrees east. All right? Bearings are directions, but they're always in relationship to north or in relationship to south. So, for example, if I was traveling from this point here to this point, right, I could describe that as what's my angle from north towards the east? Because remember, it goes north, south, east, west, like this. So this bearing might be, if let's say this angle right here was 25 degrees, then I'd say I'm going at a bearing of north 25 degrees east. Does that make sense? all right? Or if I was going from this point over here to this point, it might be, and let's say this angle was 20 here, it might say, oh, I'm going at an angle of north, 20 degrees west. Does this make sense? All right? And we could also say if I was going from this point to this point, I might be, heading off, let's say that was 15 degrees, I'd say I'm going south 15 degrees east. All right, we always start with north-south and then say how are we angled towards the east or the west. Okay? All right, those are just little examples to help us understand bearing. So in this case, it says on a small lake, a child swam from point A to point B at a bearing of north 28 degrees east. That means this angle right here is 28 degrees because we're heading north, but we're angled 28 degrees to the east. All right? The child then swam to point C at a bearing of north 58 degrees west. So here's north, and 58 degrees to the west means this angle right here would be 58 degrees up here. Does that make sense? All right? Yes? That's the bearing to go from here to here. You have to say, how is that in terms of north-south? Right? Or north and then to the west. Point C is 800 meters due north of the starting point, point A. So how many total meters did the child swim? Well, this was the path that the child swam, from here to here, and then from here to here. So we really need the distance from A to B, and then from B to C. All right? In order to do this problem, I think we're going to need to figure out this angle here. We need this angle because that's the angle across from the side that we know, right? So can we figure out what that angle is going to be? That wasn't given to us. This is where you use all of your fine geometry skills, right? Well, let me give this as a hint. If I draw this line in right here, this north-south line, what would be this angle here? Why 28?
Something opposite angle or something.
What is it?
Coterminal.
Not coterminal.
Like,
One after the second.
Interior? What kind of interior? Alternate interior angle. So this angle's
Zero.
this angle's 28 degrees, this angle's 58, and you know that these three angles added together have to add up to 180, correct? So what's this angle going to be here in between? 58 and 28 is, right, we're adding 58 and 28 and subtracting from 180, correct? So that's going to leave how much for this angle? 94? Do people agree? Yeah. So if
Yes,
this
ma'am.
angle here is 94 degrees, I think you're in business. I'm going to just put a dot, dot, dot on this problem. Dot, dot, dot. I expect you to finish this one up. You're going to have to use law of sines now to find this side, right? You're going to have to say sine of 94 over 800, right? Sine of 94 degrees over 800 equals, oh, wait a second.
No.
Well, let's go with this one first. This side here, because we can say equals, this is 28 degrees here, right?
Yeah.
Correct? So we can say equals sine of 28 degrees over, that would be side A here, right? Everybody agree? So you can do that. And then what else? I guess we need this angle up top, don't we? To help us find side C, we're going to need this angle. How are we going to find that one? Subtract from 180, right? Because we already know this one's 28 and this one's 94, so that leaves us with what? 58. You could also use alternate interior
Yeah, I
angles.
was about
with
to
this.
say.
Alternate interior angles with that one, sure. And so this is 58, so you can say, you know, sine of 94 over 800 equals sine of 58 over C and solve for that. Does this make sense? And then you're going to add those two side lengths together to get the total distance that the child swam. All right, so I put a big dot, dot, dot on this, so you are finishing this one up.
Okay.
Okay, what else do I have for you? We talked about these. Okay, area of an oblique triangle. So now we're talking about how do we find the area of an oblique triangle, a triangle that's not a right triangle. All right, and the formula that we have in this section, keep in mind that like this, no, that's not a very straight line. Let's say that's the height. This is A, B, C, right? And the formula for the area would be half the base, which in this case would be C, right? Times the height, which would be H. Would you agree with that? If we knew the height. Area would be half the base, which is C, times the height, which is H. Agreed? But we know that H, here, this is side B over here, right? This is side A over here. We know that the height, H, can be related to angle A using SOHCAHTOA. So H, let me back up. So the sine of angle A is equal to what over what? Use SOHCAHTOA just on this triangle. What would sine of angle A be equal to? H over B, opposite over hypotenuse, H over B, and that means that H is equal to B times the sine of A. So that means our formula could be written area equals 1/2 C times B times the sine of angle A. So there's our formula for the area of this triangle. Half the base times the height, but we were able to finagle the height and write it in terms of B and sine of A. So that's what we have right here. That's this one. Area is 1/2 B times C times the sine of A. So we move those around. Multiplication is commutative, that's okay. But what if we were trying to, rearrange this formula? It could be any time it's A times B then times the sine of C, or 1/2 A times C times the sine of B. So it doesn't have to be angle A that you're given. Okay, so we already talked about that. So let's take a look at this example. Find the area of an triangular lot. That doesn't look good. Find the area of a triangular lot containing side lengths that measure 24 yards, 18 yards, and form an angle of 80 degrees. So we're trying to find the area of a triangular lot that contains side lengths, let's say that are 24 yards, 18 yards, and form an angle of 80 degrees. Let's say that's an 80-degree angle. So we're trying to find the area of this lot. And we're going to use one of these formulas. Area is half B times C times the sine of A. So the area is going to be 1/2 what times the sine of what? Can you fill in those blanks for me? This area formula works if you're given, let's go back up to our picture up here. If you're given an angle and you're given two sides. So the sine of angle A, and you're given two sides, but the two sides have to be surrounding that angle, right? The angle has to be the included angle between those two sides. And that's exactly what we have here. So what are we going to write down? Kayla Powell. Uh-huh.
1/2 24 times 18 times side of 80.
Do people agree with that?
Yeah.
Okay, so go ahead and work that out. Calculators. So I need 0.5 or 1/2 times 24 times 18 times the sine, nope, times, come on, okay, gotcha. All right, times the sine of 80 degrees. All right, and did you get 212.7? What units are we talking about? What is it? Square yards. Are we okay with this? All right, that's the area of that triangular lot. Okay, I think that, that's our little picture from before. Okay, I think that's it for this 6.1 lesson. I do want to take a quick look at some things from 6.2. Or give you 2 method test preps.
Let's do it. Method test prep.
Method test preps, 2 of them. Can you do
Project.
15 and 16?
Let's do the project quiz.
15 and 16? All right, let's do this. All right. So let's see.
Combination?
Sophomore.
Sophomores are.
They're going to have to come in outside of class. Sophomores, you will need to come in outside of class time to do these 2 method test preps.
Quiz, like, is it like another picture quiz?
Yeah, it's a picture quiz.
All right, that's it for this video.
How about?
Thanks for watching, and sorry you had to fast forward through a fire
It would be
drill.
kind of unfair to let the sophomores miss so much.